Alright guys, so if you haven't seen the short video yet, we're setting up a bit of a 3D printed solar array thing up in the shed here. I've got 31 of these 250 watt panels that I've got to put up that are just sitting around the place that I should be using, so we will make some videos about putting them on the roof of this shed coming soon kind of thing. But there's a few things we've got to do. We've got to have enough storage that these can run uninterrupted, because you don't want to fail prints due to interruptions. Then we need to find a product that we can manufacture and sell straight out of the shed without any failures. So that's what we're going to do, and they can go on eBay and get sold. So then I'm using my solar power to actually make me some money. Now, what we have here is Xantrex ProSign 1000. This is what's going to run the printers. Currently I'm charging Milwaukee batteries and stuff as well, but I've got a watt hour meter in here. We're going to go until this watt hour is pegged at 9,999 kilowatt hours. So I want to pull 10 megawatts with this beast out of, I've got 6 lots of these I think, which is a 7S 180 amp hour 26 volt battery. Got the Dali 100 amp BMS on there, so I can pull up to 2000 watts, 2400 watts out of there pretty comfortably before I run out of BMS. And this, as you probably would have noticed, is actually a 12 volt inverter. So what we're going to do, I'm going to use my two Solar King 120 amp lithiums that we recovered from a factory fire. They were e-waste. They're actually melted. So we've got a couple of those lithium iron phosphates down there. So they're phosphates. These are lipos. They're actually pouch cells. So we need to make an enclosure or a shelf for those as well. And we'll have 6 of them. So we'll have somewhere in the order of 50 kilowatt hours. They're a whole electric car battery. And to get the power from those down into our little Solar Kings down there, so 3 kilowatt hours stored down there, we have 2 red arcs. We've got this one, which is a BC-DC 1220, so it's a 20 amp DC-DC, and this one up here is for charging a 12 volt battery off a 24 volt plus input, and it puts out 13.8 volts at 60 amps. So it's a really powerful passive cooled step down. We've actually got another one on one of the trucks that we just got that we're probably not going to need, so we'll probably be able to put 2 of those side by side. We have, to deal with some of our solar input, before we buy an all-in-one inverter solar charger controller thing, we have a 60 amp PWM Morningstar, and we have a 30 amp EP Ever up here. We've got more charge controllers we can play with. We've got the Blue Power clone that we could use as well, which is programmable. So currently this big battery is at 26 volts with nearly 14 amps going in. So we've done a total of 42 kilowatt hours into this battery so far. The only reason we're not running straight off the 24 volt pack is I don't have a good 24 volt inverter. I have this, which is a good inverter. I also have this, which is a Phoenix 1200, which is a grade inverter as well. This one's probably not as good in the way of cooling, but here's another pack that we've just got ready. So basically we have to parallel this with that pack, and we're going to parallel every connection with a fuse on it, including the main connections. So that Dali BMS is going to balance probably 3 of these. So we'll have 3 180 amp hour packs balanced by this Dali. Now, I did have this BMS on there, you may remember originally. This is also a Dali, but it's a 24 volt 16 amp BMS. That had that whole pack with 40 kilowatt hours in and out sitting within 0.1 of a volt. So they are very, very, very well balanced. So I probably put this together a month and a half ago with just one solar panel laying outside in the sun, and pulled 40 kilowatt hours out of it. No stress at all, and it was well balanced. So what we're going to do is I'm going to make bus bars for these. All of the first pack to 7th pack will go to their own bus bars. They'll be managed by a couple of dailies. Should involve a bit of stuffing around and some wiring, but it's okay, we can do that. So the goal is to never actually have that battery full. The idea is for that battery to keep these batteries always full. And then we make some projects with them. So these are the first ones I've made of this style. We've just done a test of these 4x6 18650 holders, like so. And they fit quite nice. I'm going to tidy these up, print some of these up for sale, but we're also going to use some because I have thousands and thousands and thousands of 18650s here. Like, we'd be pushing 10,000 at this point, I suppose, which I haven't used for anything yet, and we really need to. Oh yeah, we just got to clean the, just a bit of slaggy stuff in there. We might put one more in there and see if we can get them to go together. Probably didn't need the adhesion layer around the outside. That's probably a bunch of unnecessary mess. But I have 4 of these 3D printers which are currently sitting there doing not much. So just as a bit of a sideline thing, just ticking over, making a bit of money, we should get them out and get them doing something. Because we pile all this money into things, and then if you don't use it, it's a bit of a waste of time. And got the shed space. I've got the, can't say free, but low cost electricity. Let me get that on there, I'll come back. Yeah, they're pretty good. So that's a good model. We can definitely make some cell packs out of them. And yeah, like I said, I've got piles and piles of 18650s kicking around that I've already tested. Most of these are already tested. I think I've got 4 buckets like this full. So yeah, we need to go through and sort through them for capacity and do that. And then the next ones that we open up, we'll test all with this rig as well. But yeah, so we're 1.7 kilowatt hours in, and unfortunately lots to go, but this Xantrex inverter puts up with it and stays going, we'll buy a really big one of them to run the house with. If it doesn't, we'll know about it, because we'll be able to do updates for months and months and months to come. It's a big goal, but 10,000 kilowatt hours off grid is definitely a dream. I've got into the thousands before with other systems, and that was pretty cool. But yeah, more the better, of course. Go and get some more solar panels hooked up to this so we can get some more charge in, tidy up all this wiring, get rid of all these loose ones, and get some more of these side by side so we can make some serious power. So if that's something that interests you guys, yeah, I'll be 3D printing with a bunch of solar, so that'd be cool. With these Ender 3s, I think that's a Pro, I can't remember. I've got 3 Ender 3s and a Kriya and an ANET A10, so we'll run all of them, we'll hook all this gear up, and yeah, see how much work we can get done with it all. Thanks for watching, I'll catch you on the next video, and yeah, there's batteries to charge and 3D printing to do. This solar panel's a bit sad, so don't feel upset that I'm using it as a bench. It was on top of a pack of 20 of them, and I stuck a bunch of stuff on there and then drove them around with the forklift, so there's like little dents on the backside, so it's probably not perfect anymore, but it makes a very nice, cool looking bench. I've always wanted to have a desk made out of solar panels, so I'll probably do that at some stage too. I paid $20 each for these. Thanks for watching, guys. Catch you in the next vid.